Okay, so in this video we're going to look at differentiation, but the application of differentiation, why we use it and in what context we would apply the process of differentiation. There is a whole other video just going through the method, because the method in and of itself needs a lot of practice and that process. So watch through that video. It's probably worth watching through that video first, okay? So you really have a good handle on how to differentiate before we jump into these questions then where we actually are applying that method in the different contexts. So there's two key things that I want to revise over first, and one is the slope, okay? These are two key elements. So remember, the slope measures the steepness of a line. Okay, if we remember that from our coordinate geometry of a line, and if a line is going in this direction, it has a positive slope, and a line going in this direction has a negative slope. And the measurement of that, so if it's a high value, so for example, a 5, that would imply that it's very steep. If it's a negative 5, it's a steep line going in that direction. If it's a positive 5, it's a steep line going in that direction. Steeper than, for example, a 2, a negative 2 would be going in that direction, but not as steep a line as a line that has a negative 5. It's the 5 that's key there in comparison to the 2, and if both are negative, of course, that's the direction of the line. And here, of course, if you have a plus 5, as I said, that plus 5 line will be much steeper than a line that has a slope of plus 2. Okay, so just to recap, because we're going to talk about slope an awful lot with regards to differentiation. So slope measures the steepness of a line. The other key thing I want to revise over is tangent. A tangent, okay? Now, a tangent is a line that touches a curve or graph at only one point. Okay, so if you have a graph like this, for example, we might have a tangent here at this point, which would be just a line, just roughly drawing it there, touching that curve at that point. Okay, so that would be a tangent. Okay, so the key thing is that when you differentiate, you get the form of the slope of every tangent to the function. Okay, now I know that's very wordy, so we're going to look at this now in a context straight away. But you have to always bring it back to the fact that when you differentiate a function, when you do that method and that process, what you are getting is the form of the slope of every tangent to the function. So let's take this function here, which is f of x is equal to x squared. Okay, so we have this tangent here, right, touching the graph at the point 2, 4, and we have this tangent here. Now this one is very close to the graph, but it's touching it here at this point, which is actually minus 3, 9. Now the thing is, if we have the function f of x is equal to x squared and we differentiate it, what we'll get, of course, is when we bring the power down, we'll get 2, keep the x, take 1 away from the power, we get 1. So in other words, we get 2x. 2x, of course, isn't the slope because the slope is a number. So 2x is just the form of the slope of that line, and it's also the form of the slope of that line, and it's the form of the slope of any tangent line to that curve. So of course, to distinguish, because that obviously has a very different slope than that line, and in order to get what the actual value of the slope is, you need to know, well, at which point do you want it? Because the tangent that's at that point 2, 4 is very different than the tangent that is at the point minus 3, 9. And the slope of that tangent, which is obviously in a positive direction, is going to be a different slope than the slope of that tangent, which is obviously in a negative direction. Okay, so although that is the form of both those slopes, in order to find the actual value of the slope, what we need to do is we need to know at which point do you want it at. So if we're talking at the point 2, 4, where 2 is the x-coordinate and 4 is the y-coordinate, then what I'm going to do is I'm going to take the form of my slope and I'm going to sub in the x-coordinate, so the 2. So we get 4. So 4 is the slope of that tangent there. So now to figure out the slope of this tangent at the point minus 3, 9, where that's the x-coordinate, that's the y-coordinate. Again, I've differentiated, so I know the form of the slope, but in order to get the actual value of the slope at that point, I'm going to sub in the minus 3. And 2 times minus 3 is minus 6. And that makes more sense. 6 implies it's a steeper line than 4, and the fact that it's negative means that it's obviously going in that direction rather than that direction where that is always a positive slope. Okay, so to recap, when you differentiate, you get the form of the slope of every tangent to the function. To get the actual slope of a particular tangent, you need to know the point where that tangent meets the graph, and then sub in the x value of that coordinate point. Okay, so let's try this example. Find the slope of the tangent to the curve at the given point in each of the following functions, and this is our first function. So again, watch out for this terminology because it's very wordy, but the slope of the tangent to the curve is what you get when you differentiate and sub in your point. And so the process of differentiation will get you the slope of the tangent when you sub in your x value from the point. So let's do that. So if we have y equals this, we'll differentiate, and therefore we'll get dy dx equals, bring down the power, take 1 away, minus 4x becomes minus 4, and 5 as a number, of course, becomes 0. So we get 6x minus 4. That's the form of the slope of every tangent to that curve, but we want the tangent that's at the point 1, 4. So we're going to sub in that x-coordinate value 1, and so we get 6 times 1 minus 4, which works out to be, of course, 2. So 2 is the slope of the tangent to that curve at that point. In other words, 2 is the slope of that line, that tangent line. Okay, so pause the video and try this question. We want the slope of the tangent of the curve at this point. Work out what the value of that slope is going to be. And so when we differentiate, we're going to get f dash x. We're going to bring down the power, keep the x, take 1 away from the power. Bring down the 2, keep the 2x, take 1 away from the power. And then 6x becomes just 6, of course, and 5 becomes 0. So we're left with 3x squared minus 4x. 2 times 2, of course, is 4. So 4x plus 6. If we have, that's the form, of course, but we want the very tangent that's at that point. So when that's the x-coordinate, so I'm going to sub in that minus 2. And we get 26. So 26 is the slope of that tangent line that is touching that curve at that point. Okay, let's take a look at this example. This time we're being asked to find the equation of the tangent to the curve y equals 3x squared plus 4x minus 5 at the point 1, 2. Now, the equation of the tangent, well, the tangent, remember, is just a line. So what we're really being asked here is for the equation of a line. And the equation of a line, remember from our coordinate geometry of the line formula, is, of course, this. So this is the formula that we basically need to fill in. And if you remember from coordinate geometry of the line, the two things that you need for the equation of a line is you need m, which of course is the slope, and you need x1, y1, a point. Well, we have a point, So automatically we have our x1, y1. So the only thing we need to focus on getting is the slope. So we basically want the slope of the tangent. And remember, slope of a tangent is what you get when you differentiate. So we're going to take our function and we'll differentiate it. So y equals 3x squared plus 4x minus 5. Differentiating that, we bring down the power, of course. Take 1 away. And differentiating 4x, you get 4. Differentiating minus 5, you get 0. So tidying this up, we have 6x plus 4. That, of course, is the form of the slope of every tangent to the curve. To get the exact slope at that point, we have to, of course, sub in that point. So 1, 2, it's the x we need to sub in. So subbing in 1 for the x, we get, of course, 10. So 10 is the slope. So now we have the slope. And we still have our point, of course, x1, y1, 1, 2. Let's sub in. y1 is, of course, 2. The slope is, of course, 10. X minus x1 is, of course, 1. Tidying this up, we'll multiply out the brackets and we get y minus 2 equals 10x minus 10. Add 2 to both sides to tidy up the number work, and we're left with y equals 10x minus 8. And that is the equation of the tangent. Okay, let's try this question. Find the x value of the point at which the slope of the tangent to the curve y equals 8 plus 2x minus x squared is 6. Now again, it's very wordy, but you just want to be pulling out the key pieces of information. And here we can see that the slope of the tangent is 6. Now remember, slope of the tangent is what you get when you differentiate. So that is basically telling me that the differential, in other words, the result from when you differentiate, is 6. Okay, that's what they're telling me when they say the slope of the tangent is 6. So what I'm going to do is I'm going to take my function, I'm going to differentiate it, and I'm going to put it equal to 6, because that's what it tells me in the information in the question. So if y is equal to 8 plus 2x minus x squared, we're going to differentiate it, and we're going to put it equal to 6, and then of course you see we'll be able to solve for the x value. Pause the video if you feel confident and see how you get on with this yourselves. So dy dx, 8 of course differentiates to 0, 2x differentiates to 2, and minus x squared differentiates to minus 2x. There's my differential. Well, if the differential is equal to 6, because they tell me the slope of the tangent is 6, that means 2 minus 2x is equal to 6. And so to solve the equation, take away 2 from both sides. We get 4. Now to get rid of the minus 2, which is being multiplied, of course, to the x, we divide both sides by minus 2. And I get x is equal to minus 2. So there we go. There's the x value of the point where the slope of the tangent to that curve works out to be 6. Now, they've only asked for the x value in this question, but watch out for when they ask for the full coordinate point. And obviously for a full coordinate point, you need the x value and the corresponding y value. So when you solve to get your x value, what you would then have to do is take that x value and sub it back into the original to get the corresponding y. That's if they'd asked for the coordinate point. Let's try a question like that. Okay, so try this question. At what point on the curve, y equals x squared minus 3x plus 7, is the slope of the tangent 3? Okay, pause the video, see how you get on with this. So you're being told that the slope of the tangent is 3, okay? Which means your differential, whatever you get after you differentiate, is equal to 3. So that's what we have to work with, okay? And that's what we're going to do. So take your y equals x squared minus 3x plus 7, and we will differentiate it. X squared differentiates to 2x, minus 3x differentiates to minus 3, and 7, of course, differentiates to 0. So that gives you 2x minus 3 equals 3, because that differential, there's my differential, is equal to 3. And now we get to solve. Add 3 to both sides, we get 2x is equal to 6. Divide both sides by 2, and we get x is equal to 3. So there we go. There's our x coordinate point. But when they ask for the point on the curve, they don't just want the x, they of course need the y coordinate point as well. So what we're going to do is we're going to take that x value and we're going to sub it back into the original to get the corresponding y value. So if x is equal to 3 and y is equal to x squared minus 3x plus 7, then we'll sub in that 3 for the x and we will get the corresponding value, and it works out to be 7. So the point is 3, 7. Okay, so now we're going to look at finding turning points. And another way of describing turning points is to describe them as stationary points, or maximum points, or minimum points, okay? So watch out for all of these different ways of describing turning points. Okay, so anytime they ask about finding any of these points, we are going to use the same method and approach. So let's take a look graphically at what this means. If you have a turning point, okay, here for example we have a turning point. This would be considered a maximum point because it's a highest point on the curve here. And one thing about the tangent at that point, if I just draw a tangent, in other words, a line that will touch the curve once only, if it is touching the curve at the turning point, in this case it's the maximum turning point, also known as a stationary point because it's kind of stopped moving at a point here until it keeps turning again, if that makes sense. So that's why it can be referred to as a stationary point. But the key thing about the tangent at these points is that, well, it's flat, isn't it? And that means that the slope of the tangent is 0. So looking here at this example where we have it down here, and this would be one of the minimum points. Again, it's a turning point, it's a stationary point, but it's a minimum point. And if I draw a tangent to that curve at that point, again, we can see it's going to be a horizontal flat line. So again, the slope of that tangent will, of course, be 0. So to recap, at these points, the slope of the tangent is 0. And of course, remember, the slope of the tangent is what you get when you differentiate. In other words, the differential, which is the result of the differentiation, always will be 0. And that's the key bit of information we're then going to use. Okay, so let's try this example. So if you feel confident, press pause. What we're asked here is to find the turning point. And the minute you see those words, turning point or stationary point or maximum point or minimum point, remember all of those things, we are going to, of course, do the differential and put it equal to 0, because at the turning point, the key thing that we know is that tangent is flat. In other words, the slope is 0, there's no steepness to that line, and therefore when we differentiate, we will get 0. The slope of the tangent, in other words, the differential, will equal 0. So let's do that. So we have y equals x squared plus 2x plus 1. So when we differentiate it, we get, of course, dy dx. That's the notation if we have y equals. Bring down the power, take 1 away. 2x differentiates to 2, 1 differentiates to 0. We know now that's the form of the slope of every tangent to the curve. And of course, we know that the slope of the tangent that we're talking about at the turning point is, of course, 0. So the slope of the tangent at the turning point is 0. And now if we solve this, we'll find the x coordinate of that turning point, where that tangent is flat. So solving this, we get 2x is equal to minus 2, divide both sides by 2, and we get x is equal to minus 1. And that is our x coordinate. Now, just like the previous example though, That's your x value, but of course if you want a point, you need both the x point or the x coordinate and the y coordinate. So we're going to take our x value and we're going to sub it right back into the original to get the corresponding y value. So if x is equal to -1 and y is equal to x squared plus 2x plus 1, we'll sub in -1 for the x, and we get 1 minus 2 plus 1, which of course happens to be 0. So the x coordinate is -1 and the y coordinate is 0. And there is the turning point where the tangent to the curve at that point is flat, and therefore the slope of that tangent is 0. Okay, so now we're going to talk about proving that a point is a maximum or a minimum. So if we look back at the last example again, we can see that we got the turning point, but we don't know from that coordinate point whether that was a maximum turning point or a minimum turning point. Now, if you're familiar with your quadratics, of course, if you remember that a positive x squared is always going to give you a U shape, then you'd know that we must be talking about this turning point, which is obviously a minimum. But sometimes you won't know from looking at the graph, especially if it's a more complicated graph than just a standard quadratic. And in which case, we'd have to be able to show or prove, especially if it specifically asks me to do that in a question, I need to show or prove that that is, in fact, for example, a minimum in this question. I know for sure it's a turning point because I've solved it. And when I put the differential equal to 0, this is the point that I got. But if I wasn't sure that it was a minimum point, how could I prove that in fact it was? So in order to do that, we must double differentiate. This is the notation used when you double differentiate, by the way. When you double differentiate, if you get a value that is less than 0, it's going to show you that it's a maximum point that you're dealing with. If you get a value that is greater than 0, it shows you that it's a minimum point that you're dealing with. It kind of goes against what you would imagine it to be. The less than 0 is actually the max, and the greater than 0 is the min. Now, sometimes you get a value straight away when you double differentiate. If you don't, you may have to sub in the x coordinate point. So you may have to sub in the x coordinate point in order to get a value. If when you double differentiate, you still get something with an x in it, you'll need to sub in your point, okay, that turning point, whatever that point is that you're trying to prove is a max or min, sub that x value in, and then you'll get a value. And when you get a value, you'll determine whether it's less than 0 or greater than 0, and that will tell you whether it's a max or a min. Right, let's take a look at this then. Let's take a look at it in relationship to the previous example. So here we go. We had found our point is -1, 0. We kind of know already from our knowledge of quadratics, but let's say we still have to go ahead and prove that it is in fact a minimum turning point. What I'm going to do, of course, I've differentiated once here, and now I'm going to differentiate again. Okay, because you must double differentiate. So take your answer here, 2x plus 2, differentiating 2x, you get 2, differentiating 2, you get 0. Okay, so I've got a value straight away. I don't need to sub in a value for x. I don't have an x here. I have a value straight away. That value, of course, is greater than 0, so that tells me it is a minimum point. Okay, so try this example. Find the coordinates of the two turning points of y equals x cubed minus 3x squared plus 5 and determine whether each point is a maximum or minimum one. So, again, your keyword you're looking out for here is turning points. We know when we're being asked for a turning point, we want to get the differential and put it equal to 0, okay? So that's what we're going to do. So y equals x cubed minus 3x squared plus 5. Differentiating that, we get dy dx. Bring down the power, take 1 away, we get 3x squared. Minus 3x squared differentiated, bring down the power, take 1 away. We get this. 5 differentiated is 0. So we basically have 3x squared minus 6x. That's the differential. Put it equal to 0 because at a turning point the slope of the tangent is 0. The tangent is flat at a turning point. So now we have this to solve. Now the minute you see a power of 2, it is of course a quadratic. And you have two options to solve a quadratic. You can either factorize to solve or use the minus b formula. Now there's a whole separate video on solving quadratics, so if you're unsure about it and you need to revise it, do check out that video. The easiest thing that I'm going to do here, and I think it's the easiest thing that most pupils find to do for quadratics, is to use the minus b formula. Okay, and the minus b formula is in the log tables, remember. So here it is. And the first thing you want to identify is what is your A, what is your B, and what is your C. Your A is always, of course, the number before the x squared term, which in this case is 3. The B is always the number before the x term, which is minus 6. And the C is always the number at the end, and there's no number at the end here, so C is going to be 0. So A equals 3, B equals minus 6, and C is 0. So let's sub it in now. So instead of minus b, it'll be minus, and of course minus 6, whatever you're subbing in, keep brackets around it, remember. Square root of b squared minus 4ac. All over 2a. So 3 for the a here and here, and c, of course, is 0. If you're confident, you can type the whole thing into the calculator using the plus first, and then go back and change it to a minus for the second solution. If not, a good thing to do sometimes is to just do this bit in the calculator first. That's the way I'm going to do it here. So I have x equals minus 6 plus or minus the square root of, and all I'm going to do is what I have highlighted in green on the calculator. So I have minus 6 squared minus 4 times 3 times 0. And it is, of course, 36 all over 2 times 3, of course, is 6. Now I'm going to type this into the calculator. So I'm going to get my fraction button up. It's a minus 6. I'm going to do the plus first. I can't put both of them in, of course, at the same time. This is what gives you the two solutions. Do the plus first, square 36, and down the bottom 6. So the first solution is x is equal to 2. And the second solution is when I go back and change that plus to a minus, and I get 0. So x is equal to 2, or x is equal to 0. Okay, so they're the x coordinates of the two turning points, but now I've got to go back and get the corresponding y coordinate values. So remember, what we do is we take our x values and we've got to sub it right back into the original, and that's how we get the remainder of our points. Always remember, you need not just the x but the y coordinate point as well with a question like this. So when x is equal to 2 and our y, of course, is equal to x cubed minus 3x squared plus 5, subbing the 2 in, I get 2 cubed minus 3 times 2 squared plus 5, which works out to be 8 minus 12 plus 5, which of course is 1. 2, 1 is the first solution. Now we'll take x equals 0, and again we're going to sub it into the original function to get the corresponding y value. So 0 cubed minus 3 times 0 squared plus 5 is equal to 0 minus 0 plus 5, which of course is equal to 5. So that point is when the x coordinate is 0, the y coordinate is 5. So they are my two turning points. So if we go back to the original question, we now have to determine whether each point is a maximum or minimum. So remember, whenever we're having to prove or show that we've got a max or a min, that's when we have got to double differentiate. Okay, so this is the information I've figured out already. There's my two turning points. That was my original function. That was what I got when I first differentiated, and now I'm going to differentiate again. Bring down the power, take 1 away, and minus 6x differentiates to minus 6. So that's 6x minus 6. Now we haven't got a value yet, so what we must do now is use our information from our points. If I have 2, 1 is one of the points and the x coordinate is 2, that means I'm going to sub that in here for the x. So I get 12 minus 6, which of course is 6. 6 is greater than 0, which means that that point there, 2, 1, is a minimum. Now I'm going to take the point 0, 5, where the x coordinate is of course 0, and sub that in, so I get a value. That's 0 minus 6, which is minus 6, which of course is less than 0, which means that point there, 0, 5, is a maximum.